Today we have learned more about the homogeneous and non-homogeneous semiconductor. First, we have learned about degenerate semiconductor, and as you can see in this energy band diagram, it represents intrinsic, and for this it represents n-doped energy band diagram, and this is heavily doped n-type. As you can see, more we dope, the Fermi level goes near to conduction band. And this is the equation for non-degenerate semiconductor. And next we have learned about current flow in homogeneous semiconductor. And what you have to focus in this page is this equation, and this is the equation for drift velocity for electron, and this is drift velocity for hole. And as you can see, for what is different from electron and hole is each sign that goes like in front of mobility. And drift current is a summation of electron drift current and hole drift current. And this is the equation we have learned. And next we have learned about carrier scattering. And if ionized donor, the hole is going far away from ionized donor, but electrons tends to close to the ionized donor because it has positive sign. And as for the different opposite case, if the ionized acceptor, the hole is getting closer to the ionized acceptor because it has negative sign, but in the opposite, electron goes far from the ionized acceptor because it has same sign. And we call this force as Coulombic force. And next we have learned about lattice scattering. And as you can see in this page, there is two types of scattering. One is lattice phonon scattering and one is surface roughness scattering. Lattice scattering is happen when the electron carrier goes through the lattice like this. Then the lattice is lattice or the carrier affected by each lattice structure. And for the surface roughness scattering is occurring because of each surface roughness like this. And this is the Matheson's rule, and we have to memorize this. And next we have learned about temperature dependency of mobility. As you can see in this diagram, the blue represents impurity scattering, limited mobility, and green represents phonon scattering, limited mobility, and the red represents the summation, the more dopant. And this red diagram tends to follow the lower mobility like this. Yes, thank you.